Bjarne, what have you done? Oh, hi. C++ is inherently unsafe. I mean, it's better than C, right? In C, you can get away with, I don't know, assigning to a const, and all the compiler is going to do is give you a warning, which you, of course, will ignore. You all ignore warnings, right? And C++ is better, right? If you try to assign to a const, you'll get a compilation error, which is safer. But then again, the same language introduced constcast, which is intended specifically to circumvent the safety mechanism that it just introduced. So what gives C++? Conclusion, don't do C++. Go learn Rust, gardening, whatever. Thank you for attending my talk. Have a nice rest of the day. Thank you. But since you're here, let's talk about it. Maybe I can help you avoid, shooting yourself in the foot or stepping on a landmine that will blow your whole leg off. But before we do that, let me, hello, someone's not working. Okay, maybe that was the bug of the lecture, and from now on it will be smooth. Who am I and why should you listen? Hi, my name is Assaf Tzur-El, and I help. I love to help. I love to create order from chaos. I love to give people all the things I learned during 30 years in the business. Teach you all the mistakes that I did so that you won't have to do them yourselves. I write code. I do architecture. I teach programming lessons and classes and courses and lectures and all that. And today, as I said, I'd like to help you avoid shooting yourself in the foot and all that. And I'd like to talk about our common goal, which is working software. Yeah, it's not about writing code. Okay, the real goal here is some working system. It might be software system. It might be software that you're writing for some hardware. Okay, writing more code is not our goal. It's not even our profession. I mean, it's part of what we do, but we read requirements, we read the spec, we read other people's code, and our own code from 2 months ago, which we don't remember, right? Who wrote this stuff? Oh, it's me, 2 months ago, yeah. And then we write some code, yes, but then we write tests, and we run the tests. We compile, we build, we debug. We do lots of things. Writing code is just a tiny fraction of what we really do. And the goal, again, is reach working software. And C++ makes it harder, right? C++, as I said, is inherently unsafe. And it has this assumption, if I may paraphrase Chitov and Rossum from Python, C++ assumes that we are all responsible adults. The fact that we can assign to a const doesn't mean that we should, right? And if I may quote my uncle Benjamin, with great power comes great responsibility, of course. So let's see what we need to do in order to have working software. Well, first of all, the first hurdle is syntax errors. No, you don't write them, but I sometimes type weird stuff. But for that, I have a compiler, right? It yells at me. This is why I turn wall, warning all. You all do that? Of course you do. And its sibling? Where are? right? Treat all warnings as errors. Of course we do that. Okay, so it compiles, it runs, but it doesn't really do what I wanted it to do, what I intended it to do. There are logical errors. And of course, for this, we have full coverage of unit tests, and you all have full coverage unit tests, right? And integration tests, and system tests, and functional tests, and end-to-end tests, and I'm running out of fingers here. There are all kinds of names for this, but I really hope you're doing this, and if not, talk to me later. And then, that's the problem we have with most languages. But then we have unique problems for C++. We have all these safety issues, right? All this buffer overflows and allocations and deallocations and all these nice things, booby traps, just waiting to spring at us. And on top of that, C++ is unpredictable, right? So let's, oops, sorry. This is the unpredictable, yeah? And if this one was a, then this one is, yeah, right? And I'd like to discuss these last two things, safety and unpredictability. And let's start with unpredictability. I guess at least some of you know what I'm going to talk about. So those who do, I'll see you in 2 minutes. The rest of you, follow me. So first of all, we have something called undefined behavior. In the standard defines a few things as undefined. If that's not contradiction, then I don't know what is. It comes from C. C started it all. There's someone else we can blame, right? Ritchie and Thompson, your fault. And it says something like this, the defined manual, the standard. Undefined behavior is behavior for which this document, the standard, imposes no requirements. For example, class example, division by 0. The result of division by 0, I won't say the exact wording, is undefined, which means it can be int max, it can be int min, it could be 3 on Sundays and format your hard drive whenever it feels like it. Think about it. You have a compiler that generates code that, if you divide by 0, whenever it feels like it, it formats your hard drive, and this is C++ compliant compiler. You're using this language?
Hopefully not.
Yeah, I have a slide on that. Okay, so this is undefined behavior, but we have more. We have unspecified behavior. Now, if I ask my child, what's the difference? It's the same thing. But no, the standard has a different meaning to unspecified. Unspecified behavior is behavior that depends on implementation, that's compiler. The implementation may choose from a set of appropriately defined behavior. So at least it says something about properly defined behavior, that's nice. But, for example, let's say I have function f, okay, which receives 3 parameters. But instead of sending 1, 2, 3, I call the functions a, b, and c. The standard says that a, b, and c will be called, will get their values, their returned values, and send them as arguments to f. But in which order? Will the code call A, then B, then C, or will it be C, then B, then A? Actually, any one of the 6 permutations is totally valid. And I really hope you're not counting on any specific order, because the compiler can do whatever it wants. It can format your hard drive, but it can call them in any way it wants anytime you call this function. Unspecified behavior. Thank you, C. Then we have implementation-defined behavior, and that's behavior that depends on and is documented by the implementation. So there are things that by reading the documentation of the compiler, at least you know what it's going to do. Each compiler can do whatever it wants, but it should be consistent within the compiler. For example, size of long. What's the size of long on your system? 32 bits. 32 bits going once. 64. 64 going once. Going twice. 128. Do I hear 128? Yeah, that's it. So it can be anything, but at least when you have this compiler running on this bitness, then at least you know that you'll get a consistent answer whenever you do size of long. Okay? So it's inconsistent, but at least within the compiler it is. It's inconsistent within the language. And there are more. I'm not going to bother you with all of them. I'll just mention conditionally supported behavior. That's a behavior that is supported, but conditionally, if the compiler feels like it. For example, hashtag pragma, right? Any compiler can do whatever it wants. It can support pragma warning or not. And the list is very long, of course. There is what's called locale-specific behavior. As a Hebrew speaker, I can tell you a lot about that. Yeah, and even when it's not officially some defined behavior, there is some convoluting wording. For example, iterator invalidation. Ever heard of that? It's when you have an iterator referencing an element in a container, and then you resize the container. You delete something or you add something. So the standard said that by that, you invalidated all iterators referencing that container. What does that mean? Well, if you dig deep enough, then you'll find out that it's undefined behavior. Nice. Okay. Wow. One good thing I'm going to say about C, and if you quote me, I'll deny that, of course, is that although the standard is strewn with all of these things all over the place, at least they have this appendix, an annex of all these unpredictabilities. There's a list of undefined behaviors. All the undefined behaviors throughout the document is concentrated in a single place, in one list. And then there's a list of unspecified behavior, et cetera, et cetera. So at least when you're writing code, you have a checklist to check against, am I doing something stupid? Something unpredictable. And in C++, there is no such annex. So may I use this stage and address the C++ standard committee, please add this annex. If you're not going to eliminate all this unpredictable behavior, at least help us out, will you? Okay, so C++ is unpredictable, but I started with the fact that it's unsafe to use. And I'm going to use safety and security more or less interchangeably throughout this lecture, because there is safe coding and there is secure coding, and some people will tell you it's totally different things, and some people will say this is the same thing. So I'm not going to get into that. For our purposes, safety, security, same thing. We're not going to talk about hacking password and stuff like that. We're going to talk about buffer overflows and stuff like that. So, what kind of safety do we have? And maybe you'd like to write this down, because this is going to be like a checklist that you can check your code against. Am I doing everything right when I'm writing my code? For example, am I using lifetime safety properly? Constructor, destructor, virtual destructor, if you're using inheritance. Of course, you remember that, yeah? And you don't inherit from virtual destructor-less classes. Using RAI, preventing use after free, all these things under lifetime safety. Then we have bound safety. Don't access your arrays -1, right? Don't access your vector plus, I don't know, size plus something. All these things. Then there's type safety. Type checking, casts, null pointer dereferencing. What does it have to do with type safety? What's the type of a null pointer? Null PTRT. It's not the type of whatever class it is you're pointing at. It's null PTRT. It's its own type. Okay, so type safety. Did I tell you to bring barf bags? Okay, so try not to get sick from the next one. Thread safety, race conditions, all these interesting things. I love them, not. And runtime checks. Okay, so I wrote all my code, but as you know, runtime is the realm of uncertainty, and all plans can't withstand the runtime and all these things. So when we get to runtime, it's a different game, right? We need to think about the unthinkable because, you know, as much as you created bulletproof and foolproof, they'll come up with a better fool. So, and of course there are combinations like thread and lifetime. You're deleting an object in one thread but still using it in another. Or type and runtime when you get inputs from a user and parse it into an int. But you have to check whether it has a decimal point or maybe invalid characters or stuff like that. Okay, C++ is unsafe. It's unpredictable. What do we do? That's a big question. And fortunately, I have the answer. Where's the angel choir? I don't know, something happened to the special effects. Anyway, there is an answer. It's a simple one, and you're not gonna like it. Because the answer is migrate to a safer language. And it's not me saying that. It's all these acronyms. The US government, you probably heard of all these initiatives to stop using C++. So you have the CISA, which is, I'm not good with acronyms, so I'm going to read it from here. Cybersecurity and Infrastructure Security Agencies. That's two securities in one acronym. There's the NSA, National Security Agencies, or the spooks. There is the ONCD, that's the White House Office of the National Cyber Director. There are two cybers here, only in here. And there are lots of other acronyms, all telling us, suggesting, threatening that we don't use C++. Stop using C++ immediately, they said in 2022. Then in 2023, by 2026, we will not allow runtime written in C or C++ anywhere. And now in 2024, they came up with, please, by 2030, please have a plan to migrate away from C++. And I'm here to tell you not to worry. Not gonna happen. It's not practical. I mean, we have existing code base, right? Talk to me after you migrate whole of Linux out of C, or Windows, or I don't know, the whole code running in the F-35 fighter and other airplanes and submarines and cars and medical equipment. And the world isn't going to stop in 2030, okay? Because there's no way we're throwing away all that code. Then what about the ecosystem, right? We have invested in tools. We have IDEs, we have compilers, we have static analysis tools, we have runtime analysis tools, we have libraries. That's infrastructure that other people wrote and I can use without writing everything myself. and there is you. You are part of the ecosystem, right? You're not going to become JavaScript developers. Has any of you became JavaScript developer from me doing this? No, yeah, figured that. So there's also the fact that requirements force us to use C++. If we have real-time requirements, then buy Java, buy C#, and if we need efficiency, then Python, JavaScript, you can go. And if we need low-level access, then Rust, see ya. And we're not going to talk about Go, right? Go away, go. Yeah, no go. Yeah. So the requirements force us to use C++, and there's no alternative. There is no language that does all the things that C++ can do and is safe and is predictable. Not right now. Not even you, Rust. So this is not the answer. So what is? Well, there is no answer. There are solutions. And because it's no answer, it's no magic, then it must be hard work. And the hard work begins with standards. Well, first of all, there is the C++ standard. After blaming it with all humanity's misfortunes, I have to say one good thing for it. It does provide us with safety mechanisms. For example, const, okay? Safer const than C, at least. Instead of one almighty cast, we have a few weaker ones. Instead of using raw pointers, C++ introduced smart pointers. All these things, that's nice of it. But it's not enough. And there have been a few initiatives to make C++ safer. One of them, for example, is actually called Safe C++. Go to safecpp.org. It's an initiative by Sean Baxter, if you ever heard of him. Smart guy. You should check out the safecpp.org, just at least to learn about it. He suggests adding stuff to the standard to make it safer. For example, he suggests a safe keyword that you'll add to a function signature. And by doing so, the compiler won't allow you to do certain unsafe things inside the function, like do stuff with the raw pointers. And if you call another function from this function, then this other function will have to be also safe. Similar to a const function that can access only other const methods, stuff like that. So similar to that. Then there are real standard, like the standard International Standard Organization, ISO 26262, fondly named FUSA. That's functional safety in automotive, in road vehicle, sorry. And this standard deals with mechanical quality and quality requirements actually, electronic, and yes, software requirements to make it safer and more reliable. But even this standard is more about the process. It requires you, for example, to have official documented requirements. It requires you to have verify that the software architectural design is suitable to satisfy the software safety requirements. Was that written by a lawyer or what? Anyway, it's more about the process, right? It's not down to earth, things that we can actually use in our day-to-day work. For that, we have maybe coding practices. Coding practices is things that get us into good habits. For example, have you ever heard of the OWASP Top 10? OWASP is a security organization, and it came up with like 10 items that you should consider when writing secure software. So some of it is about authentication, which I don't know if you use, maybe not. Some of it is about logging and observability, which you should use, no matter what you do. And actually, only one of them is really about the quality of the code that you're writing. And even that is not C++ specific. So I don't know how good it is for our purposes. It's something that you should read, okay, and should use in your daily work. But again, it's not specific enough. Maybe defensive programming. Have you heard of defensive programming? Show of hands. A few of you. Okay. Defensive programming is, if you ever heard of the X-Files, it's trust no one. You get a parameter, argument actually. Don't trust it. Check it yourself. It's not enough that you wrote that you should send only, I don't know, integers above 3. You should check in your code, in your function, that you're actually been given 3. Don't trust any input from users. Okay, sanitize everything. Okay, it's a bit of a paranoid approach to programming, but you know that the fact that you're paranoid doesn't mean that the runtime is not out there to get you. So this is also a good habit to have. And there is the Secure by Design initiative, or rather, Secures by Designs initiatives, because there are a few of those, and they're all called this name, although they're different. For example, all these acronyms of the US government, they have a Secure by Design initiative, and you can read it on the website of the White House, actually. And Google has its own white papers called Secure by Design. And you should, and there are other methodologies, for example. Microsoft's SDL, Security Development Lifecycle, that's also something that should promote security from the get-go, from your design. Start by designing secure code and move on from there. But again, it's not enough. It's habits, it's processes, it's general directions. I don't have the word in English for this, so I'll switch to Hebrew. I need tachlis, right? I need, boots on the ground. I need, enforcement. Yeah, I need something to tell me what to do. I need rules. And there are actually quite a few of those. For example, there is the JSF Secure C++ guidelines. Started with the JSF, the Joint Strike Fighter initiative, something that, project, sorry, that became the F-35 fighter. So all the code there obeys the rules set in this JSF specifications. And there are others. There is AutoSAR, there's MISRA, there's CISEC, there are all kinds of other acronyms. And that's only half of what we need. But because we're talking about enforcement, and in order to enforce something, you need someone who will do it. And we have tools for that. We have static analysis tools. That's tools that can read our code and tell us, do we obey the rules or are we violating any of them? Okay, and we have, you probably heard of Clang Tidy, thank you. And there's Sonar, Sonar Cube, Sonar Lint, Sonar IDE, they just changed their name. And I'm going to talk today about something called the MISRA guidelines as an example, but also because I think they're pretty good, and also because they're widely used. Now, I'm not going to get into a popularity contest. I'm not going to say that they're the most popular or very popular or whatever. They are widely used throughout the industry, and I'll tell you why in a second. But first, let's talk about the Motor Industry Software Reliability Association. And I'm sorry I have this terrible Israeli accent, but this was supposed to be a British accent because this is a British government thing. And translation to Americans here, the motor industry is the automotive industry, just to make sure we all understand it. And it started as an initiative of the British government to make better and more reliable software that runs inside vehicles. And today it's a consortium led by automakers or motor industry in the UK, but also other makers like BMW, which is German, and universities and others. And they started with guidelines for C, then added C++ to the mix in 2008. And we're going to talk about MISRA C++ 3, which came in 2023, of course. And they cover up to C++ 17. Yeah, I know there is 23, but who really is using C++ 23 in production? I mean, I know too many companies that are still contemplating the move to this dangerous new thing called C++ 11. So C++ 17 is good enough. And MISRA has 179 guidelines, which for a programmer like me looks like a lot. There are too many rules that I have to follow and read and make sure that I don't violate. But if you think about the almost 2,000 pages of the standard, then it's very little. And as I said, there are, that was another slide, there are tools that will help me, right? I don't have to think about everything. All these static analysis tools will warn me if I'm violating any of these guidelines. So why don't we start by checking out some of them. Here you go, your first MISRA C++ 2023 guideline. Rule number 961, the goto statement should not be used. I didn't need you for that. My kindergarten teacher used to tell us all, kids, never use goto, right? Your teacher also used to tell you that? Yeah, yeah. From the first moment you learned C, I guess, don't use goto. Okay, so that makes sense. And I'd like to point out a few of the guideline components to show you how much thought was put into this. So let's start with classification. It can be each guideline can be either a rule or a directive. A rule is something that you can know what it means by just reading the rule. That's it, okay? Goto statement should not be used. There is a rationale. There is usually, I didn't put here everything, okay? They're usually code samples, and it's very comprehensive. On the other hand, a directive is something that requires more. It requires requirements and spec and things like that. For example, a guideline, a directive, floating point arithmetic should be used appropriately. Now, if you have ever used floating point, you know that these are very strange creatures. They have numbers, but they also have infinite and minus infinite, and they don't have zero. They have two, positive and negative zero, and they also have none, which is not a number, and if that's not enough, they also have minus none. And if you have none and minus none, are these equal or not? And talking about equality, did you ever try to compare two floating point numbers? They're never the same, right? There's always one bit off. So you need to talk about tolerance and epsilon and all these things. And this is why it can't get into the rule, right? Because It depends on your requirements. What's your tolerance? All these things. What do you do with a none? So that one is a directive. Okay, so you won't be able to use a static analysis tool for that because it depends on your requirements. Okay, let's talk about category. Here we have mandatory, required, and advisory. Mandatory, okay, advisory, you can understand for yourselves. Required is the interesting part. Required means that you need to obey this rule, or else, unless you document it properly. There's a way to do documentation. So if you decide to deviate from the rule, you can, but there must be a very good reason and you have to document it. Okay? So what do we usually do? We write our code, we realize that it doesn't comply with the rule. Now what? So I'd like to ignore the rule. And the rule says, yeah, no problem, ignore me, but document it. So instead of thinking of another line of code to replace that line, now you have to write a whole document. Is it worth the effort? That's your problem. Okay, so it's actually a very smart thing. Or if you're using a void pointer, for example, which is forbidden, that's required not to use void pointers. But what happens if I have this external library that returns a void pointer? Okay, it calls malloc or something. Well, I need to document it, right? So if I'm calling this library 5 times, I have to document it 5 times? Well, you could wrap that call inside a function and have the function return some real type. Okay, so and then you'll only have to write your excuses, this documentation, only once. Okay, so it persuades you to do the right thing, or at least minimize your efforts, which is, I think it's very smart. Another thing I want to show you is decidability. Any guideline can be either decidable or non-decidable. And decidability is actually answering the question that a static analysis tool can answer the question, does this code comply with that rule? Okay, so if, for example, the go-to statement should not be used, that's pretty easy for a static tool analysis, right? Static analysis tool, right? You just, either you have a go-to statement or not. Very simple. The floating point thing, not so much. Okay, so that's decidable and undecidable. And there are rules or guidelines that concern a single translation unit or the whole scope of the whole system. Let's take a look at another example. The structure of a switch statement shall be appropriate. Okay, so it's required, meaning obey or document. It's decidable, of course, right? If you have a switch statement, then what? It should be appropriate. Appropriate, and call that decidable? Well, yes, because there's more. As I said, it's very thorough. There are explanations. There's an amplification that says that the switch statement is structured appropriately when it conforms to the following restrictions, and then you have quite a few restrictions. For example, restriction number 7 is every switch statement shall have a default label. Okay, that's a no-brainer, right? So you won't fall out of your switch. But I recall this very first rule, rule 001. A function shall not contain unreachable statements. Do you see the collision here? Yeah, and the collision has a name, and it's enums, right? What happens if I have an enumeration? I do a switch on my enumeration, case this, case that, and that's it. So the other rule told me I must add a default clause, right? But this rule says a function should not contain unreachable statements. And this default will never be called because my enumeration is only this and that. Again, there is more to that. There's an amplification. And a statement in this context is unreachable if the block containing it is not reachable from the entity block of the CFG, whatever the. What it means is that we're not talking about logical unreachability, if that's a word. We're talking about real unreachability. For example, if you write code statements after the return statement, that's unreachable code. It will never be reached, right? It's not conditional. It's not logical. It's just there. So that's the rule we're talking about. So as you can see, there are contradictions. There are actually overlaps. And they're all intended to make you think twice and force you to not make mistakes and not fall into these safety problems or unpredictabilities that C++ is so good at. The thing is that now I don't only need to be a language lawyer. You know that term? In C++ you must know that term. So you have to be not only C++ language lawyer, now you have to be a MISRA advocate or something. Why? Why would I do that? What's in it for me as a developer? Well, remember our goal? Working software, not more code. And when I do this mental switch as a developer, then it starts to make sense. I want code quality. I want my code to be reliable, not to depend on some kind of weird behavior. I want it to be more maintainable, and MISRA helps me with that, right? The guidelines help me create consistent code that's easier to write, to test, to debug, to upgrade someday. Of course, it's safer, right? MISRA focuses on mission-critical systems where the price of an error is very high. It might be even human lives. So we don't want to play with that. I don't want to open the paper one day and realize that my code caused a catastrophe. And if the price that I have to pay is to be more strict when I write my code, okay, I'll do that. And it also helps me adopt better coding practices and avoid dangerous patterns, like using raw pointers, stuff like that. Then there's portability. Have you ever been into a situation when you can't upgrade some library or the underlying operating system or the compiler because it breaks? Yeah, ever happened to any of you? Okay, I admire your sincerity. Actually, it happened to me. I was once involved in a project where they ran on Linux from, it was a decade old, and ancient library versions, and they couldn't change from one processor to another to a newer one, and definitely not change their compiler. They were running, again, on GCC or something, an ancient version of GCC. Why? Because whenever they tried to change something, it broke. Why? Unpredictability. They were relying on the compiler doing certain things, and the operating system and the hardware. So they were not portable. And, I know you don't like this, but it actually makes code reviews easier. Why? Because the problem with code reviews is that I wrote the code, I inspect the code, I think my code is fine. No, this isn't good. Well, that's like your opinion, right? It's a matter of a personal taste. And there come MISRA or any guidelines and says, these things are not a matter of personal taste. This is the right way to do things. This is not how we do things. End of story. And code reviewers are nice people because they're in our teams and we know where they live. What about audits? Audits are code reviews from hell. It's an external person coming over to peek over your shoulder and tell you you're doing this wrong. What am I doing wrong? What should I do? I don't know, this is wrong, right? Ever had an audit? Yeah, am I exaggerating? No, sadly no. So audits become easier because there are rules. Do I comply with the rules or not? If not, then my code is fine, go away. Now, why should the organization invest in these processes, these guidelines, these burdens? First of all, there is quality, and we need quality. And the organization, right, needs quality. And there are standards. You need to align with industry standards. For example, if you're dealing with vehicles, any Mobileye people here, or medical devices, or aerospace, defense, whatever you do, there are standards, and someone will hold you to that standard. For example, if you're Mobileye and you're developing software for vehicles, then you'll have to comply with ISO 26262, and although that ISO is about the process, when it comes to developing software, it says that your software should be compliant with some standard like MISRA C++. It actually names MISRA as an example. Cost and time, right? It takes more time to write each line of code, yes. But in the long run, it's easier, right? Less bugs and more efficiency. And there are the customers. If a customer sees that you have on your wall this I am MISRA compliant, then they'll regard you with higher respect. And maybe it will make your life easier, give you competitive advantage when bidding for contracts. So organizations should also be happy with MISRA and the likes. Yep, I said it once, I'll say it again. C++ is inherently unsafe. It has lots of buried landmines in the form of unpredictability and safety issues. And there's no real alternative. Don't switch to Rust. Don't go learn gardening. Not yet, at least. But there are ways to mitigate the problems. And adopting coding practices is key. And specifically, guidelines like MISRA C++ should keep both you, your customers, and your managers happy and safe. My name is Assaf Tzur-El. I love helping people. I hope I helped you today. And let me know if you need, if I may help you with your software development practices. Thank you. Do you have any questions? And we can do that in Hebrew. Okay.
It's more a note than a question. Regarding the Safe C++, we already have such thing. It's called Managed C++ in .NET of Microsoft.
The question, the comment here is we already have Managed C++ in .NET. We had Managed C++. It was as much fun as getting, extracting a tooth without surgery. It was replaced by C++ CLR. It's still .NET, so it's managed. It's not efficient. It's not real-time. I write C#, okay, sometimes, confession. But it's not a real replacement. It's not real time, it's not efficient. You can't put that in mission critical equipment with hard real-time requirements.
Okay, this is only the first part of my note. Okay, the next part is that if you introduce such a concept of safe or manage or whatever in C++, you must bridge it with unmanaged, and it will be inevitable in the end. From my bitter experience last half year, I made a bridge between a Swift on Macintosh and C++ via Objective-C. And most of the bugs I suffered from are in the bridge. Then you must
Right.
copy and create buffers with raw pointers.
Right. So there was a suggestion here. Rephrase. There was a suggestion here that if we're doing safe C++, then we also have to declare unsafety. Okay. And well, unsafety we already have here. I think I talked about it for the last 60 minutes or so. So safer C++ is what we're after, and it's different from managed, because managed means you're running a garbage collector, and again, it's not as efficient, it's not real time, it's different, it's good, right? The world is full of Java and C# and all these other languages, and it's okay. But for mission critical systems with low-level stuff, there's no replacement for C++, and the only way to do it is to go safer, not managed, I think. Ken?
In your opening slide, you mentioned something about robotics.
Okay. Here's a guy who sees sharp, pardon the pun. אני אקח את זה בעברית. היה פה באיזשהו שקף שורה אחת על תחרות רובוטיקה. יפה ששמת לב. אז כן, ביום השמיני בשבוע, בשעה 27 של היום, כשיש לי קצת זמן, אז אני גם מתנדב בכל מיני דברים. אחד מהם זה, אני שופט בתחרות רובוטיקה. מישהו מכיר FRC, ארגון FIRST? יש פה כמה, אוקיי. אז לאלה שלא, אתם יודעים מה, אני אשכרה אקח כמה דקות לענות על זה. בואו נראה כמה זמן יש לנו. יש לנו עוד קצת זמן, נהדר. אז בואו נספר לכם קצת על FRC, כי אם יש משהו שאני אוהב לדבר עליו יותר מקוד, זה על ארגון FIRST ועל FRC. דמיינו לעצמכם תחרות של רובוטים, אוקיי? על משהו בגודל מגרש כדורסל. 3 רובוטים נגד 3 רובוטים, כל רובוט סדר גודל של מכונת כביסה, אבל הוא לא מכונת כביסה, כן? זה רובוט עם זרועות, עם גלגלים, הכל וזה. 3 רובוטים נגד 3 רובוטים. כמה זמן היה לוקח לכם להרים מאפס רובוט שמסוגל להתחרות בזה? אוקיי, שמרו את התשובה לעצמכם. מה היה קורה אם זה היה תלמידי תיכון? כמה זמן היה לוקח לכם להרים אם אתם הייתם תלמידי תיכון? עכשיו תחשבו על זה שהתחרות משתנה כל שנה. שנה אחת זה לזרוק פריסבי, רובוט שאמור להרים פריסבי מהרצפה ולזרוק אותו ולקלוע. שנה אחת זה לראות כדורים או להתמסר, כל שנה זה משתנה. כמה זמן היה לוקח לכם להרים את זה? חודשיים. מהיום שמודיעים לכם מה התחרות השנה עד שהתחרות קורית, חודשיים. תלמידי תיכון. ומתוך משהו כמו 65 קבוצות שיש בארץ, 65 קבוצות מגיעות לתחרות, זאת אומרת 100% הצלחה. זה משהו מדהים לדעתי, אני גאה לקחת בזה חלק, למרות שאני לא חלק מהקבוצה, כי אני קצת זקן בשביל זה, אבל אני שופט בתחרות הזאת שנקראת FRC, First Robotics Competition, מאז 2008, וזה לא רק בגלל הקטע של רובוטיקה, וזה לא רק הקטע של ללמד תלמידי תיכון מקצועות STEM וכזה, זה בגלל שהתחרות הזאת היא אשכרה בונה בני אדם. זאת אומרת, למשל, התחרות הזאת מקדמת שיתוף פעולה. איך תחרות מקדמת שיתוף פעולה? אז אשכרה זה קורה. ואם בא לכם להיות חלק מזה, אז דברו איתי אחרי, עונת התחרות מתחילה ממש עוד רגע, התחרויות עצמם במרץ. והנה זה הפך להיות מהרצאה לקמפיין גיוס המונים, לשפוט או להיות מנטורים של קבוצות בתחרות רובוטיקה לתיכונים, ממש ממש מדהימה. תודה על ההזדמנות.